Last time, when you tuned in, we started the webinar series about ComPredict. So really about meeting the company, meet and learn about our technology. And today, we want to talk about how to virtualize wheel force transducers. If you missed the first webinar, you can also watch the recording on YouTube. It's already online. Feel free to watch it there. And maybe also a first glimpse on the next webinar in 2 weeks, which will be about a deep dive into our virtual sensor platform, which also includes a live demo of our ComPredict VSP. But let's focus on today's topic and really how to virtualize wheel force transducers with virtual sensors. Let's have a glimpse on our agenda. First of all, we will talk about how to use virtual sensors in R&D in general. Then we will give you use case examples. And at the end, we will also have a look on the virtual sensor performance evaluation.
All right, but first, a little off-topic recap from our side. So last week, we attended the Automotive Testing Expo in Stuttgart. It was a great experience. We had great customer interest and some very insightful conversations with our customers, especially regarding our virtual sensor platform, which is showcased in the next webinar session. Also, Stefan and I had the opportunity to present a real customer project tackling the exact topic of today, which is cool. If you missed that, no problem. You can find the slides from the Testing Expo where we are presenting this customer use case at the organizer's webpage. You can find it by just clicking on the URL in the bottom right corner of the screen.
Perfect. Thank you, Daniel, for the short recap. I also have to say it was really an amazing event for us to get in touch with customers, partners, and also industry experts on our topics, and really looking forward to be there next year again. But now let's start with our today's webinar's content. And our first agenda point is really how to use virtual sensors in R&D. But before we start how to use it, I will maybe have a few words on why you should use virtual sensors in your automotive R&D. And when we have a look at the current automotive R&D environment, we noted 3 major challenges. Of course, as you all know, nowadays development cycles are normally up to 3 to 5 years, I would say. And the challenge also with increasing competitiveness on the market and also with the latest technology is really to decrease these development cycles. So really fasten them and really come up to a cycle which at maximum lasts 3 years. And it's better to have 1 or 2 years even to be really competitive in this challenging environment nowadays. Secondly, we noticed that there's a clear need to improve the data availability in automotive R&D and also the data quality along the whole vehicle life cycle. So a lot of OEMs have a lot of data in place, but often it's not enough, and also they don't know exactly how to use it. The third challenge is really to decrease the hardware dependency in today's automotive environment and integrate software and virtual testing opportunities the best way possible. And how you could do this is, of course, by integrating virtual sensors into R&D. So with this technology, you can really face these challenges and overcome them. And virtual sensors, as we said last time, are really intelligent algorithms, completely AI-based and purely software-based, which means that you can easily deploy them via cloud, or you can even deploy them in your vehicles. And this has different benefits for our customers. So for example, if you deploy a virtual sensor via cloud into your development vehicles, you have in no time data from not only one development vehicle, which was equipped with a hardware sensor, you have data from several vehicles or a whole development fleet when you are deploying our virtual sensors via cloud in this development fleet, and this without any additional hardware. Further, of course, you have to also the benefit to really have a retrospective determination of engineering parameters. What does it mean? Maybe you already have in place some measurement data from previous measurement campaigns, but you missed to mount a hardware sensor, for example. You will never get outputs for this sensor. But with virtual sensors, you can even do retrospective calculating. And when you deploy it, upload the data, you get the virtual sensor outputs for these vehicles in the past as they would have a hardware sensor on it. And this is completely new also in this field. And lastly, you can also access, for example, like wheel force transducer data from real customer usage and really from serious production vehicles. And this is completely new, that you do not only have wheel force transducer data for a development vehicle, but also the possibility via software to really drive on the road and get real data from real customer usage. And this is also why we are really proud that we were able to present together with Suzuki a few weeks ago our joint technical paper about the implementation of virtual sensors for the virtualization of wheel force transducers to evaluate actual use of customer vehicles. Together with Suzuki, we presented this technical paper at the JSAE Annual Congress 2024 in Yokohama. And you all should, I think, have received already the technical paper from our marketing department, from VJ. And if not, please let us know, and we will, of course, send it to you. Or you can now also download the whole paper on our website on Compredict AI.
All right, so let's get into the actual topic of today. In today's webinar, we would like to give you an idea on the virtual sensor implementation with one of our three major application areas, the addition of measurement capabilities. The idea of this application of virtual sensors is to virtualize equipment that is usually used in R&D procedures of OEMs or tier ones for situations like component dimensioning, vehicle durability analysis, or vehicle dynamics analysis. As with all our virtual sensors, we are just utilizing the data that is available and accessible in vehicles anyway to enable these kind of measurement capabilities, as Stefan just told us. And as you can see, we have a comprehensive portfolio of virtual sensors for this application area already in place that have been tested and are basically ready for action. Besides WFT or wheel force transducers, which we will talk about in a minute, we have virtual sensors for force and torque estimation on specific components or locations that can create valuable insights on vehicle design and usage, like, for example, damper and tie rod forces. And especially relevant for current structures of electric vehicles, we also offer a virtual sensor for the drive shaft torque estimation. So if this is of interest for you, let us definitely know if you want to hear more about this. So we can definitely do a dedicated webinar session on this as well. But today, let's focus on one of our favorites, which is the virtualization of a wheel force transducer. But in order to do so, we first have to understand what a wheel force transducer actually is or what it's doing. Basically, a wheel force transducer is a device that is replacing the original rims within vehicle testing scenarios. You can see an application example here on the screenshot to the right. And as you can see, it's a quite complex structure and is therefore not applicable to serious production vehicles, alongside other reasons, like from a cost perspective, obviously, but we will come to that in a moment as well. Wheel force transducer, as I said, actually captures and accurately captures the forces and torques between the wheel and the road, or in other words, directly at the vehicle hub, which is an essential information for decision-making processes within chassis departments or for chassis components, such like the suspension system. There are various types and dimensions available, so not only for passenger vehicles, as you can see here in this picture, but also for trucks or even heavy machines like mining machines, for example. It's a rather costly device, I have to say that, and I think this picture makes it clear already. That takes some initial work for preparation, for calibration in order to set it up properly. in order to be as accurate as possible. As I said, making it nearly impossible to be implemented on scale, like for example, for an entire development vehicle fleet or even in series production. But this is exactly where the virtual sensor technology comes in handy, as we are enabling exactly these implementation strategies with our technology. So now that we know what a WeForce transducer actually is, let's get a little more closer on the actual process on how we are virtualizing these kinds of equipments. It all starts with a reference vehicle from our customer that is basically actually equipped with WeForce transducers serving as the ground truth for the virtual sensor calibration. In order to calibrate a virtual sensor for WeForce transducers or for any other reference equipment, we basically need two things of this reference vehicle. First, we need CAN bus data that serve as the input feature for virtual sensors. These are usually gathered by data logging devices, which are equipped to R&D vehicles anyway. And this data is then streamed to a cloud platform like our virtual sensor platform. The second thing that we need is reference data from the actual hardware sensor, in this case, the WeForce transducer, again, serving as the target signal in order to be reconstructed by the virtual sensors. Both data streams are then uploaded to our virtual sensor platform where the actual magic of the calibration happens. But as we know, we will come to that topic next week. And after the calibration is done on the platform fully automatically, the virtual sensor has to live somewhere. And our approach within R&D scenarios is usually to deploy it on cloud, as R&D vehicles such as long runners or durability testers are usually also equipped with data logging devices. And when these data streams from these other vehicles, like durability testers, like long runners or any kind of other vehicles, are uploaded to our virtual sensor platform, we can then evaluate the WeForce transducer results of these vehicles just utilizing the CAN bus signals, even though these vehicles have never been equipped with WeForce transducers before. So in a nutshell, and we like to say this sentence all the time, with this approach, we are making series production vehicles or series production-like vehicles as smart as fully equipped R&D vehicles. For a proper calibration and to ensure that the virtual sensors are actually accurate as possible, the data quality from this reference vehicle that I was mentioning is obviously essential. And the best way to ensure that this performance is basically set, a dedicated measurement campaign is the best way to go, like we did it for a previous customer project. So what we did is we took a fully prepared vehicle, a fully equipped vehicle with WeForce transducers to the UTEC SRAM test track in France, a very cool place to be, I can tell you that. And we conducted a dedicated measurement campaign for this scenario. The overall goal of this measurement campaign was to capture enough data to cover, I would say, the entire spectrum of situations that a vehicle can witness over its entire lifetime. So what we did is we tested on several mass configurations. We drove specific scenarios like high-speed driving scenarios, or for example, we also drove on corrugated roads to get this kind of vehicle behavior. The vehicle that we used here was basically equipped with two things. On the one hand side, 4 Kistler Rodyne WeForce transducers, and on the other side, obviously, a data logging device with full CAN bus access. What is eventually most interesting for you is how the virtual sensors are performing. So let's talk about this. Basically, the target quantities, as it's quite obvious, of the virtual sensors are aligned with the physical quantities that serve as the output of the WeForce transducer. So the lateral, the longitudinal, and the vertical force, and the respective torques. In this case, we're just showcasing the forces, but I can tell you that the torques are as accurate as the forces. And in order to evaluate the performance of our virtual sensors, we calculate several performance metrics. These metrics basically, or with this metrics, we are trying to incorporate a so-called multi-objective optimization in order to capture, as I said, the entire spectrum. So what we do is we calculate for the average deviation in comparison to the reference signal, which is basically done by the root mean square error, for example. We also calculate a damage value, or as we call it, a duty value and relative damage difference using rainflow counting. But also, and what is especially relevant if we are, for example, talking about sports cars, the peaks are one of the most relevant things that a virtual sensor has to deliver. So we obviously take these peak evaluations into account as well. And as I said, the goal of the virtual sensor is to, as the hardware reference, cover and evaluate the entire frequency spectrum of what a vehicle can witness. So for example, low frequency representing the handling excitation, or high frequencies representing the road excitation, including the peaks, obviously. And this obviously gives various benefits for our customers. I think with that, back to Stefan.
Yeah, thank you very much, Daniel, for explaining what a wheel force transducer is, how accurate also our virtual sensors are, and of course, now it's all about the benefits. So really, to sum it up, the implementation of virtual sensors brings several benefits for our customers. Not only have we seen that the expansion of your development fleet can easily be done, also the retrospective evaluation of durability parameters is now possible. And also, you are not as reliant as of now on hardware, which means that you can also avoid testing issues due to equipment failures, because we are speaking, of course, of pure software here. And this, of course, also has the impact for our customers that you can really reduce the risk of recalls, because you have a higher and more qualitative data set you can rely on before really going into serious production. So this, of course, increased durability insights, and we all know how expensive recalls can be, especially if you have an evaluation end-to-end on this one. So here we have a clear impact. Also, you have for the first time really the possibility to understand the actual use of customer vehicles with the outputs from a wheel force transducer. And last but not least, we also have with the software piece the implementation possibility and capability for serious production vehicles, which was just not possible in the past. And all in all, you also accelerate, of course, time to market and really increase your competitiveness in nowadays automotive R&D environment. And yeah, this was our content for today's webinar. And before we are coming to our Q&A session, I would first, of course, inform you that we will see each other hopefully in 2 weeks again, and where we will give you like a deep dive into our virtual sensor platform, where you can automatically calibrate and deploy these virtual sensors, even without prior knowledge in ML, which is quite a thing, I would say, and really happy to give you this demo in 2 weeks. And secondly, of course, to say thank you to all of you that you watched and listened to our webinar too. And now, really happy for all the questions to answer.